Sometimes you're going to be asked to write the equation of a line, and so point-slope form really comes in handy. For example, if I want to write the equation of a line that passes through these 2 points, you could use slope-intercept form. You could calculate a slope. You could try to figure out what the y-intercept would be. It's definitely doable. But point-slope form is actually designed for people to use to write the equations of lines. So you'll notice here I actually have the slope formula. Slope is equal to y2 minus y1 over x2 minus x1. Point-slope form is actually a version of the slope formula. It's just written in a different way. Basically, it's taken out of fractional form. So if you multiply the numerator by x2 minus x1, and then you balance that on the other side by multiplying by x2 minus x1, you'll see that you can divide this out of the numerator and denominator and get 1. And you're left with an equation that looks like this. Now the actual point-slope form equation is changed just slightly. It's designed so you put 1 point in that the line passes through, and then you have x and y variables to represent all of the other possible points on the line. So usually instead of having a y2, they use a y variable. Instead of having an x2, they have an x variable. So you're filling in an x coordinate that your line passes through. You're filling in a y coordinate that your line passes through. And then you're filling in a slope. Okay? So in this particular case, the slope's pretty easy to find. I can do y2 minus y1. That's negative 2 minus 2. Okay? I can take 5 minus negative 3. Okay, and that's going to be negative 4 on top. That's going to give me 8 on the bottom. That's going to give me a slope of negative 1/2. Okay? So in point-slope form, I can basically start filling in things here. My slope is going to be negative 1/2. I would fill that in for m. Okay? And then you can take either one of the 2 points. It's interesting, that line will be the same line regardless of which point it's passing through. If you put it into slope-intercept form, you'll actually end up with the same equation. So, I can use the point negative 3. I can fill that in for x1. I can fill in 2 for y1. Just make sure you're using the same 2 coordinates. They need to be an actual point on the line. I don't want to jump from one coordinate to the other. And anyway, we can go ahead and fill this in. And so my equation is y minus 2 equals negative 1/2 times x. Be careful here, it's x minus negative 3, so that's going to be x plus 3. Okay? If you're just asked to write an equation, that's an equation, you're done. If you need to put it in slope-intercept form, you can distribute. And so in this case, we're going to get negative 1/2 x. Negative 1/2 times 3 is negative 1/2, so that's going to be minus 3/2 or minus 1/2. And that's equal to y minus 2. You can add 2 to both sides, and you're going to be left with y is equal to, it's going to be negative 1/2 x, and when I add 2 to both sides, I'm going to get plus 1/2. So if you need it in slope-intercept form, you can put it in slope-intercept form. If you just need to write an equation of a line for some reason, really you can leave it in point-slope form, and that's totally fine. So that's how you write the equation of a line.